Thank you very much for the introduction. Hi, everybody. So my name is Imtiaz Madni. I'm based in Perth, Western Australia. And as Barry mentioned, I'm currently working as the technical lead Asia Pacific for a global company, and also engaged with the IT as a casual lecturer and thesis supervisor. I've got a PhD degree in electrical and electronics engineering. So that's where my background is, into power systems and also industrial automation systems. So been working in Australia for almost 15 years now. And previously I've worked and lived in several different countries. I've worked in Middle East and also South Korea for several years. Uh, Worked with Samsung, and then in Japan for some time, and in China for almost 2 years with Huawei. And yeah, so during my PhD and currently with my work in a global organization, so I've worked with several companies in different countries, like in US and the UK especially. So I've been like all over the place, and I have had the opportunity to work with several different um, nationalities and people from different cultural backgrounds. And so yeah, that's a little bit about myself. So yeah, I teach some units with EIT as a casual lecturer. So with the industrial automation, masters of industrial automation and bachelors as well, and then some units with electrical engineering. Uh, so today's topic, harnessing the power of Industry 4. So as you may know, Industry 4 is revolutionizing the world, and there is a lot happening in terms of technological breakthroughs. So that's where this topic is very important, because um, the near future is going to be about transformation. So there will be a lot of transformation happening in terms of manufacturing. So um, which is similar to what we are experiencing with the energy transition. So at the same time, manufacturing transition and transformation is also very important. So that's why we chose this topic to give you an overview of what is actually the Industry 4 and what are the key components. Obviously, in a webinar, we can't really go into too much detail, so I will try to cover different aspects of what it is and um, what are different components which are making it possible. So in terms of contents, we'll be covering like an introduction to Industry 4 and its key components. And then we'll talk about those components, like the IoT, Internet of Things. You must be familiar with this. And then we'll talk about big data and analytics, like what's happening with the machine learning and artificial intelligence. And we'll look into some case studies, like a quick check to like what has already been done, and then we'll talk about some challenges related to the transformation, so that what is the current scenario and what are the barriers and how we can overcome those barriers. So it could be like a lessons learned um, kind of thing. So then we'll talk about some future trends, like what are we expecting? Uh, so people are already talking about Industry 5 now. So what we expect in future to be the Industrial Revolution 5. So first of all, in introduction to Industry 4, and so I hope you guys know when all this industrialization started like 18th century, end of 18th century. So the industrial revolution one, when everything started to go machines, mechanization of our industry and the way things were done and made. So Industry 4 is the fourth revolution. So it's based on the concepts of making things much more smarter and producing or manufacturing these products in a much more smarter way. So there's a lot of focus on sustainability when we talk about Industry 4 or making things in a smarter way. So how we can make things at a much lower cost with the less waste of resources and uh, using less energy and other raw materials. So that's basically the driver for Industry 4. And we are making use of those smart technologies to achieve those goals. Um, so Industry 3, as you may know, that introduced computers into the manufacturing processes. So we made powerful machines and used computers to do some tasks and like some control and some level of control systems. Um, so Industry 4 basically focuses on connecting these devices and allowing them to communicate more efficiently. So there's uh, a lot of focus on communication. So communication, as you know, that communication is a core of automation. Without communication, obviously, we cannot achieve much automation. So Industry 4 takes it into a much higher level of communication. So with the technologies like Internet of Things. So Industry 4 marks the introduction of intelligent processes, automation, connected systems into industrial landscape. So it provides all levels uh, of manufacturing processes, the um, same level of automation. So from initial manufacturing process to product development, and then even the management of the life cycle of the products. So, like I mentioned, there's a lot of focus on sustainability. Um, so the drivers of future manufacturing are basically those capabilities which we have developed. So there are some technological breakthrough, as I mentioned. So we can now have things like additive manufacturing, and we can have cyber physical production and advanced data analytics, which are helping us to achieve those goals in terms of optimization of system, optimization of production, and optimized use of resources and energy. And then there are some policies and trends which are making things more applicable. So it means in terms of implementation of those technology, the policies and trends are also helping to means in terms of the manufacturing, there's a regionalization of manufacturing and then certification of some task in terms of manufacturing. Like we have, um, like when we talk about a manufacturing process, for example, a car manufacturing, it doesn't happen on one facility anymore. So basically, different parts that come from different factories and then together, and then we make the final product. So there's a lot of certification. So that also needs some kind of automation, obviously, to not have some bottlenecks in terms of our production. And so that's where the Industry 4 is bringing everything together so that all can be automated, and there's a lot of communication between different equipment and devices, and also at the enterprise level, there's a lot of um, communication and networks. So this here it shows the evolution of fourth industrial revolution. So as I mentioned, the first industrial revolution was like in towards late 18th century when we started doing the mechanization. So used steam and water um, and hydraulic systems to move things, right? And then the Industrial Revolution 2 was when we started producing in bulk. So that was when electricity was discovered and we had easy access to power. So then there was mass production with electricity. So that was called Industrial Revolution 2. So Industrial Revolution 3, which is more recent when there was advent of computers and semiconductors, so semiconductors because they are the fundamental components of our logical circuits. So that's when logic started coming into our manufacturing processes. And so we have automation with electronics and information technology like IT networks, and uh, then we have OT, merger of OT and IT. And Industrial Revolution 4 basically is taking it into the next level of communication. So instead of having localized networks, so now we have like a network of networks, right? So that's basically the concept of Industrial Revolution 4, and this that's the concept of Internet of Things, where we have cyber systems and physical systems. So there's one merger of cyber physical systems, basically digitization of all the processes. Um, so which is happening now, and like you mentioned, so we are already talking about the next steps, like Industrial Revolution 5, because things are developing very fast. As you may know, technologies developing at exponential rate. So we have so many breakthroughs and advances in technology. So um, it may be very soon we have some more advances in terms of our manufacturing processes. So key components are these that which I already briefly mentioned, that Internet of Things is the main component, and then we have those IT systems like machine learning and artificial intelligence, which are basically driving this revolution. And because of those data processing capabilities, now we can build cyber physical systems. And also, in terms of the advances in our um, uh, IT networks, so we have a lot of cloud computing capabilities, so where that's where big data is becoming possible, and the processing and data analytics is becoming more feasible. So smart factories obviously is a key component of industrial uh, uh, revolution 4. So Internet of Things basically refers to things here refer to those equipment and devices and instruments. So basically the concept of Internet of Things is that everything is talking to everything else. So that's making every device, every machine smart enough so they can communicate to other machines and devices by themselves without human intervention. So that makes them more efficient because they can make some decisions on their own rather than in the past, like where we had operators looking at some SCADA screens and then responding to certain events. So basically, we can automate these equipment and machines so they can take some decisions on their own based on the information they receive from several different devices. So that's where the communication is important. So IoT allows for rapid communication between machines on manufacturing floor. So the machines on factory floor are equipped with sensors and detectors and several other actuators. So they have their own physical addresses or virtual addresses, IP addresses that allows the machines to connect with the web-enabled devices. So basically, we can have remote controls as well, so we can access remotely in all those devices as well, and we can monitor and control them remotely. So that's another big driver in terms of Industry 4. So this mechanization and connectivity make it possible for large amounts of valuable data to be collected, analyzed, and exchanged. So data um, collection, data acquisition has become very, very important for this type of manufacturing, because um, we can perform some data analytics and can take some actions um, on time so that we can avoid any um, disruptions or deviations in the processes. So next is then big data. So big data basically refers to large amount of data, as the name says. So big data means large amount of data. Obviously, when we make things smarter, uh, so basically, like Internet of Things, everything is talking to everything else. So how they are talking is with data, right? So everything is becoming more data intensive. So we need to have something like big data analytics to work with such large amount of data. So that's where big data analytics are being very useful. So with the developments in terms of big data analytic techniques like machine learning and AI neural networks, so they are very um, supportive of the Industry 4 concepts, right? So we can have structured data, like which we can label. So in terms of manufacturing, like in terms of process industry, we have some structured data where we know the labels of the data, like temperature, pressure, different parameters. But there could be some unstructured data as well. So which relates to the conditions or the events happening in the process. So the beauty of these machine learning algorithms is that they can also work with the unstructured data, like unsupervised machine learning. So there are different concepts within machine learning, yeah, like supervised machine learning, which is mostly suitable for structured data. And then we have unsupervised machine learning, which works with unstructured data or semi-structured data. So then we can um, make some predictions and suggestions or recommendations. So these algorithms basically process the information received from the actual processes and process them in real time and provide some recommendations or suggestions, or even in terms of critical um, failures, they provide alarms and notifications so that we can take some action before things go wrong. So IoT is being used in different ways. Like I said, the product quality control is one of them. So based on condition monitoring. So condition monitoring is a big advantage of having these processes in our manufacturing, that we can monitor the condition of equipment and the processes in real time. So basically, in terms of quality monitoring, we can identify some parameters, basically to make sure that they remain within certain limits. So when they start deviating from their normal range, so we can identify them and take some action right away. So, for example, in terms of health monitoring of an equipment, like actuators or motors and pumps. So when their health starts deviating from the normal, then we can identify them in real time and take some action, like in terms of maintenance, so that before failure, we can um, keep them in working condition. So basically, uh, the analogy is similar to what we do with our cars. For example, when we're driving cars, so basically we from time to time, like after a few months or based on the mileage, we go for car service, right? Just to keep it in good health. So before it goes uh, into the failure mode, right? So we try to keep it in good health. So same applies to these industrial machines that with condition monitoring, we now have the ability to continuously monitor their condition. So we can be more efficient in terms of maintaining their health. So that's where this IoT is very useful. And similarly, industrial asset tracking. So that's also very useful method to keep track of your assets, where they are, and uh, how much they are being utilized. So in terms of the economics, that also helps, like you can allocate the right resources to the right jobs. So basically, the assets utilization when they're not being utilized, so you can divert them to other parts of your system where they could be utilized. The same applies to machines, like when we have this real-time monitoring, we can monitor what's their utilization rate and what we can do to improve the utilization, and probably we can come up with some different products or varieties of products so to make them useful. So um, that's another uh, benefit of using these Industry 4 processes like IoTs and big data analytics. So one of the best advantages or benefits of this Industry 4 processes like IoT and big data are the predictive maintenance. So that has been adding a lot of value already in industries which have implemented those processes. So like predictive maintenance, as the name says, so it predicts when you need to do the maintenance. So basically that saves a lot of cost. So you no longer need to do your uh, regular testing or inspection. So basically you are monitoring the data in real time. And then we use this algorithms like machine learning and other models which learn from the historical data and then provide some insights like predictions about what is going on with our equipment and when do you expect to something to deviate, and then we can plan maintenance. So basically that reduces the downtime. So basically increasing the production. So there are a lot of economic benefits in that. So as I mentioned, artificial intelligence and machine learning, they are proving very, very valuable for manufacturing as well as other industries, so they can create insights, providing visibility, predictability, and automation of operations and business processes as well. So these components basically allow manufacturing companies to take full advantage of information they generate throughout the industrial process. So we can have, like in real time, we can have some manufacturing planning. So that also gives an advantage in terms of the marketing or sales. So it can provide insights into business processes and help companies to stay one step ahead of potential issues with devices. Um, these tools then allow for more advanced automation. So basically, it's all that data we collect, then we apply these machine learning and artificial algorithms to understand um, our processes and equipment better, and we can in- increase the uptime, reducing downtime, and increasing the efficiency. So cyber physical systems, basically that's a main component of Industry 4. That's where we have integration of the cyber system, like computational world or networking world, and the physical processes. So that enables these manufacturing capabilities. Basically, we can produce stuff in real time according to the demand, right? So that's where cyber physical systems go hand in hand. So we can monitor the demand and what's going on in the market, and instantaneously we can um, provide that information to our physical systems and processes, that how much of something is required and what quality of product is, or what variety of product is required, so then it can change its production accordingly. So that's the basic um, um, objective of Industry 4, right? So sustainability. So we don't end up like in the mass production in the past, where we used to produce things in mass, um, which is good in a way that we can produce them at lower cost, but then we end up with a lot of waste, right? So basically, if something goes out of demand and you're producing in mass, so that doesn't make a lot of sense. So that's where these cyber physical systems, they are very much aware in terms of what's going on in the market, and then they can adjust the manufacturing process and the production, and not just in terms of the making products, but also how to make products, so they can also be smart in that way, and also how you can make cheaper. So like this, the distributed energy resources concept is also being implemented in the manufacturing, like which energy source at what time can give you lower cost. So that is also in real time. So they dynamically change according to what will be the best process. And also when you have, like, for example, you're using um, solar power. So when it makes sense to have higher production when there's a lot of solar, right? Then when there's less solar, so then you can ramp down your production. So that kind of interaction or integration is possible due to these cyber physical systems. And cloud computing is another key component of Industry 4. So cloud computing basically helps in uh, um, decentralization of your data. So like in the past, we used to have this localized servers and storage warehouse, like the data warehouses. So now it is all going to cloud, basically. So that because it offers several advantages. So like in terms of um, the management, so biggest advantage is that you don't have to worry about maintaining and repairing or monitoring your data warehouses or data servers. Basically, you have a specialized organization and specialized people who are doing that for you, and they offer their services to you. So then you can pay as you go for those services. So cloud computing is quickly becoming the cornerstone of virtually any Industry 4 strategy. So basically, these cloud technologies allow for easy integration of supply chain, engineering, production, sales, and service. So basically, you can sit in any part of the world and you can access the data there due to these cloud technologies. So they allow industrial companies to collect and use data from various landscapes easily. So that's where enterprise level automation uh, is getting these benefits. So these can also reduce startup costs. So for like small and medium-sized manufacturers, where you don't want to spend a lot of money right away to build your own data warehouse or servers. So then you can, like I said, pay as you go. You can subscribe to these cloud computing services and uh, use them right away. So cloud computing basically is helping in several different domains. So like you can, like I said, you can have specialized people looking after those data warehouses all the time and making sure the connectivity and security of your data. So you have 24-hour support, and you have pay as you use subscription, and then you have logistic independent, so you don't have to worry about these physical devices in your system like the warehouses or historians or other servers required. So it's easy and agile deployment, cost reduction. So focus on you can focus on core business. So rather than focusing on your data storage requirements. So there are several different models actually for cloud computing in practice at the moment. So they are called SaaS, PaaS, and IaaS. So basically, SaaS means software as a service, and then PaaS means platform as a service, and IaaS means infrastructure as a service. So it depends upon what model you follow. So then you can have those capabilities. So in terms of manufacturing, so basically this SaaS makes more sense, or some companies also go with PaaS. So where they can have these software and applications like SCADA systems, as well as this data storage capabilities and dedicated um, data centers. So then they don't have to worry about anything on their premises. So cybersecurity, as you can imagine, everything goes cloud or data dependent. So then there are some risks as well. So that's where cybersecurity comes in. So it's a very important component of Industry 4, because in the past we used to have our communication like in a typical manufacturing industry or any process industry, where we have our control systems and localized automation. So that data stayed within the site or within certain processes. So there wasn't any requirement to have some intra-network data communication. So with Industry 4, that is obviously different. So now we have this network of networks, so that data can go different places. And so obviously then there are threats in terms of hacking or doing some dodgy stuff to your processes or your businesses. So that's where cyber security is crucial to protect manufacturing systems from cyber threats and ensure data integrity. So in the past, we used to have this air gap. We called it air gap. So air gap basically means that you're physically disconnected and virtually disconnected from the other networks. But now that with Industry 4, we can't have that. So we need to make sure that we have certain um, processes in place, like cybersecurity, to ensure the data integrity and uh, deal with the malicious attacks and malware. When undergoing digital transformation to Industry 4, it is essential to consider a cybersecurity approach that encompasses IT and OT equipment, so that you can make sure that you don't have any intrusions. Then we have edge computing. Edge computing is a concept basically in terms of data processing. as the name says, edge computing. Basically, we have certain devices and processing capabilities. Processing means data processing here. So basically, to minimize the latency, so when we go like cloud connected processes and your data warehousing is now on the cloud. So obviously there are some bandwidth limitations and some data rate limitations. So that's to minimize those latencies. So we use this edge computing. Basically, that means that we process a lot of data within the facility before sending it out to our data centers. So then there is minimal load on the equipment or devices in our data centers. So demand for real-time production operations mean that some data analysis must be done at the edge, the where data is created, because we have certain response time requirements also, like certain things need to be responded in an automated process in certain time period. So that's where edge computing is used. So this minimizes the latency time from when data is produced to when a response is required. So for example, like the detection of a safety or quality issue might require real-time action with the equipment. So real time means it really needs to happen within like few hundred milliseconds or few hundred microseconds in some cases. So obviously, the time needed to send data to the enterprise cloud and then back to factory floor may be too lengthy, right? So because sometimes that data can be large size. So and also it depends on the reliability of the network. So that's why we use these edge computing so that we can process that data, critical data within the facility. So we also reduce the security risks. So that's an illustration showing like what is edge. So edge means it is at the edge of the facility. So that's where the name comes from, edge computing. So before data leaves the facility, it is processed by these edge computing devices. So then these edge computing devices did with data centers or cloud centers. So basically, then that real-time information required for our processes can be made available right away. So then we have some techniques like digital twinning. So digital twins, basically, as the name says, it's a twin of the actual process, but in digital words. So that also offers a lot of benefits that we can um, basically monitor or play with certain parameters to understand our system better and without interrupting the actual physical process, we can simulate all the processes and the required or desired set points within the virtual world. So that doesn't affect the actual process, because sometimes you want to implement some new techniques or new processes, but you don't know whether it will be effective or not. So without taking the risk to implement that on actual process, you can basically do that virtually and see what's the outcome. And then once you're confident, then you can take that to actual system. So digital twins are virtual replicas of physical assets used for simulation, analysis, and optimization in manufacturing. So that's also a part of Industry 4, right? So where we have a lot of digitization. So because of digitization, we can actually implement these digital twins, because if you're monitoring real-time data, you have the actual historical data from your plants and processes. So then you can just go ahead and virtually build the exact same plant. So a digital twin is created by pulling data from IoT sensors, devices, PLCs, and other objects connected to internet. So these manufacturers you can use digital twins to help increase productivity, improve workflows, and design new products. So by simulating a process, like I mentioned, manufacturers can test changes to the process to find ways to minimize downtime or improve capacity or introduce a different variety of a product so that without losing anything on the physical system, you can simulate and test before going um, to your facility. Like so, some use cases, like I mentioned, there are some use cases already. Several industries have opted to go for Industry 4 automation. So Mitsubishi Electric is one of them. Their plant in Thailand, which was in collaboration with True 5G and robotics company Levilai. So they created this smart factory prototype at their automation park in Thailand. So basically utilizing the same components which we discussed, the intelligent 5G network for high-speed data processing and inspection of production lines, and then autonomous mobile robots, they are called AMRs, and then artificial intelligence and reality. Um, so they have produced this, they have basically transformed to this smart factory. So basically, that is already producing benefits for them. So this is just an illustration of how they achieved this level of automation. So basically, it's an integration of physical processes with the cyber processes, so cyber physical system, and then made possible with this edge computing, like we discussed. So edge computing basically to help at the interface, and then you can use different type of communication protocol. So we call them communication protocol, like the rules and um, set of uh, laws which govern the data communication. So like there could be several different type of communication protocols at different levels. So Profinet, Ethernet, and TCP/IP. So basically, they are at this interface to edge computing, and then we have some application layer protocols like Modbus, MQTT, and DMP3, others to provide this automation at the application level. Okay, so another company is called Makino Asia. So they have also taken this path to Industry 4. They've invested around $74 million to make their factory smarter. So basically, they produce some tools and devices like CNC machines. So to meet the growing demand from customers and ensure factory machines worked at peak levels, the Makino Asia has developed voice recognition robots and robotic arms and AR-based remote assistance and also self-driving forklifts. So they all need to talk to each other, right? So that forklifts can drive themselves to stock or reload some raw materials, and then similarly the robotics, they can talk to each other too, because there could be several steps in producing their machines. So these robots and automated forklifts increase productivity at factory without additional labor. And these AR assisted reality devices allow Makino engineers based in Singapore to provide step-by-step instructions via smart glasses, so they can basically control them from anywhere in the world. So this is just an illustration of their factory floor and how they are achieving this Industry 4 automation. And then similarly, Schneider Electric's, I don't know how to pronounce that name, Lavadriol. So if there's any French guy here, they can pronounce it for me. So this facility basically in Europe, that's the Schneider Electric's industry for automation. So they have this factory which works on fourth industrial revolution processes. So factory has incorporated most up-to-date digital technologies like EcoStructure, TM. So that's basically Schneider Electric's automation suite. So the EcoStructure is also being used in several other industries as an automation suite. Basically, it's a set of different devices, edge computing, and then PLCs to automate different processes. So its first application of this EcoStructure TM resource advisor saves up to 30% on energy and adds to long-term improvement. So 30% is a big time saving. That's a quick glance of their factory and their automated processes. As you can see, there's no staff or minimal staff required at the actual facility. Everything is happening automatically. So key drivers for Industry 4, as we discussed, there are the technological developments and then policy changes and also the need of the time, like the sustainability goals. Planning and control is one driver, and then machines. Basically, we have these machines now which can work independently and autonomously. Then humans are also uh, becoming smarter. I don't want to say that they were dumb before, but means they are more technologically capable and skillful. So that's also driving this change to much more smarter and efficient processes. And O&M, like we discussed, the asset management requirement, like the need for real-time monitoring, condition monitoring, and predictive control, that's also a big time driver of industrial automation, so especially Industry 4. So, like we discussed earlier, that there are some challenges in adoption of Industry 4. So, some are technological challenges, some are uh, social challenges, like the culture and mindset. So, some people don't like the idea of going fully automated systems. Some fear about the loss of employments and joblessness, and some fear of the rise of robots, they can take over. So there are a lot of challenges in terms of social as well as technological challenges. So it's um, in terms of technological challenges, like we need to have, first of all, the workforce who is fully capable of working with these advanced technologies. And also, like our conventional systems, like the existing manufacturing system, if you have invested billions or millions of dollars into your assets, but some of the assets uh, do not have the capability to go smarter and capable of incorporating or integrating into newer systems. So there's a high cost of scaling deployments and organizational challenges, getting management buy-in for smart factory initiatives, and some technology challenges like the software and implementation partners, etc. And some security concerns also, like cybersecurity is a big challenge. And then concerns about capabilities and stability of technology and costs of deployment. So these are some challenges which uh, we need to overcome to have a wider application of Industry 4. So in addition, there are socioeconomic challenges as well. socioeconomic in a way that the fairness in terms of the capabilities, right? So um, the countries and firms which are already advanced in their technological capabilities, so they will likely reap the initial benefits, right? Because they already have the technological capabilities and also the money, for example. And so that can create a further potential gap between technological haves and have-nots. So those which are already struggling, and when the industry 4 transformation happens, then they could struggle more to keep up with their technological capability. So then obviously those companies which do have the capabilities, they will have higher advantage. So this can impact both developed and developing economies, so necessitating efforts to bridge the divide and ensure equitable access to the benefits of Industry 4. So that's where the policies and regulations need to be used for uh, the equitable access for all the people in the world. So in terms of overcoming barriers to implementation, so based on like the lessons learned, what could be the challenges in terms of the barriers? So first thing is legacy IT systems. So uh, like I said, if you have invested a lot of efforts and capital into building your IT infrastructure, then um, you might find out that it doesn't integrate with the newer systems or newer software or devices required for Industry 4. So the solution for that is before building a smart factory or retrofitting a current factory with Industry 4 technology. So you need to work on your IT groundwork and analyze state of your business management systems across R&D, procurement, purchasing, production, and warehousing. And then you need to do the assessment to validate like whether what will be the implications of Industry 4. So interoperability is also a similar challenge, like where we have the newer and older equipment. So how you can make them work together. That's interoperability, right? So many factories run a mix of newer and decades-old equipment that lacks the uh, sensors and internet connectivity crucial to smart factory, right? So yet it isn't possible to retrofit older machines, and then manufacturers don't want to replace them. So some of them also lack IT systems, so they are very dumb, like conventional machines. So then, obviously, first thing is to overcome those issues. Connecting isolated data sources has long been a challenge for manufacturers, but uh, falling sensor cost and standardized communication protocols make it easier to overcome. So like there nowadays we have this standardized uh, communication and automation protocols like Modbus and IC 61850 and uh, all other systems which are making it relatively easier for the manufacturers to move towards newer systems, and then they can keep using some conventional devices with the newer devices, so interoperability can be overcome. And cost and resource limitation. So going for Industry 4 obviously comes at a cost. So if you want to get those all advanced uh, devices and systems, and then you have to spend some money. So Smart Factory requires investments in making IoT systems compatible with older manufacturing control and execution systems. Constraints on technology investment can prevent scaling of Industry 4 projects. So instead of waiting until a complete IT architecture is defined and rolled out before implementing Industry 4 projects. So we can do a minimum viable product approach. So that's MVP approach, very commonly used in industry, right? So we can take that MVP approach that we can introduce projects on a shorter lead times and course correcting based on users' feedback. So basically, you can have a progressive change in their manufacturing. So this approach can help focus spending and also define the scope of the projects. And there's another barrier like skills gap. Like I mentioned, these advanced technologies and systems obviously require certain skill sets. So a lot of the staff who are trained to work with the conventional system, so they need to be retrained. So machine operators in smart factories must learn how to interpret new types of information and step in and fix processes when needed, and also control machines in new ways. And training on the factory floor rather than at a desk can help. So engineers also need to be trained over the newer analytical approaches and manufacturing processes. So that's uh, something which you need to keep in mind when we go for Industry 4 transformation. Similarly, change management is the same. So manufacturers should identify use cases and sites that yield quick wins and financial returns so that change management can be justified. So success of this Industry 4 project depends on employees actively using the new technology. So basically justifying that ROI, rate of return, to managers so that the change management can be easier so they can approve that changes. So another barrier is cybersecurity, like we discussed, that is a big challenge when everything goes cyber. So there are greater risks, right? So if somebody breaks in into your data communication, then they can have access to your processes and all the confidential information. So that can um, be very challenging. So that's where cloud computing can be very helpful because they're like specialized services, so they have the cybersecurity procedures already in place, so they can help with overcoming that barrier. So strategies to be adopted for Industry 4 implementation, obviously we need to define a clear vision of what we want to achieve. Like I said, there are sustainability goals, there are efficiency goals, and there are um, the the transformation goals in terms of the resource management and lean manufacturing, and then develop a comprehensive roadmap, then secure stakeholder buy-in that we need obviously some money to do that transformation, and focus on people and culture, collaborate with technology providers. Obviously, a lot of these modern systems require combined effort from the technology providers and the integrators because they need to work together because some technologies they are not used yet, so unused processes and devices, they need to work together uh, with the technology providers, and then embrace data-driven decision making. So you need to be able to trust the data analytics and what's going on in your process so that you can trust their decision making capability. So future trends, like I mentioned earlier, that we are already at Industry 4. And what's next? So smart manufacturing obviously will reshape job roles requiring new skills and fostering human machine collaboration. So that's where Industry 4 is deriving the economic growth by increasing productivity, creating new business models, and enhancing competitiveness. And also now we have real-time data and predictive analytics, so we can identify a lot of issues make our processes safer and reduce the downtimes, reduce the maintenance costs. So basically, SMEs can benefit from Industry 4 by adopting scalable technologies that improve efficiency and competitiveness. And also, we can combine digital processes or technologies with the lean principles to enhance efficiency and eliminate waste, make our world more sustainable. And the future's trend. So obviously, the social revolution started way earlier than industrial revolution, but industrial revolution obviously is a product of social revolution, and it is catching up in the pace now. So like we started from hunting society to agrarian society, and then came the industrial society. With that came the industrial revolution one, and then we have information society in the past, and now we are moving towards super smart society, which is called society 5, right? So that's the social revolution 5, but we are at industrial revolution 4, and in future we want to be able to match that. So society 5 should have industry 5, right? So that's where, as you can see here, we have different goal dimensions. They all need to merge together to achieve that. So like value dimension, and then um, goal dimensions, technology dimensions. So they have different factors which need to merge together to achieve the future goals of moving towards Industrial Revolution 5. Right, so that's the end of my presentation, and I hope it was useful, and I'm open to get any questions. Sorry, I haven't been looking at the question answers, but I can have a look now and can answer your questions. So Barry, do you want me to do it now, or you want to do your ending
I
remarks?
Yeah, you can take it. I don't see. Let me quickly check. Okay, there's one question that says how Industry 4 serves country like India after 10 years.
Um, yeah, good question. So I think we did discuss that towards the end, like how um, it could be challenging in terms of like unfair advantage to those countries which already have developed technologies and processes, and those which are developing, like India or other countries where there is technology, but it's not implemented as much on a scale, right? So that's where we need to have these policies and framework that we don't create further gaps. And it's hard to say where India would be after 10 years. Obviously, it depends upon the policymakers. But I would say that because looking at the trend and the potential, obviously there is a lot of trend these days to move manufacturing towards India, and there's a lot of skilled resources there. So I would say that in terms of Industry 4, um, we can get those resources utilized in some ways, like even everything is automated, but um, still you need people to be able to develop those processes, right? In terms of data analytics and writing the softwares and um, processing the information and monitoring the information and monitoring the automated processes. So yeah, there are some risks, like some people may lose employment, but I think there will be like a different stream of employment. So that's where policymakers need to work with people to train them to work with the newer technologies. Right. So I think that's all about questions so far.
Just
I think in the chat there are some questions.
yeah, there's one. I think there's one too. How would mechatronic play a role in the future?
Yeah, so mechatronic basically is the combination of mechanical systems and electronic systems. So it is already playing a role. So as we talk about cyber physical systems and smart machines and smart equipment, so basically that is implementation of mechatronics. So it will have a crucial role in my view in future as well. So there will be uh, opportunities for people who are skilled in electronics and mechanical and mechatronic systems. So that answers kind of the next question, which is what should be the most important skills? I wouldn't say most important because all these key elements, as we discussed, they are equally important to realize that Industry 4 system. So basically, we need to have skills in terms of data analytics, so big data. So already you see that there's a lot of focus on data science. So several different countries and organizations are pushing for people to learn more data analytical skills. So work with big data, and then also other uh, in terms of digital communication. So that's where I would say EIT's program on industrial automation is very much industry focused. So they have all those skill set which are currently required in industry. So basically, that's the thing I like about EIT is that they work with industrial stakeholders, like even some of the lecturers like myself, they are from industry, so they know what exactly is happening in the industry and what would we need in future so we can teach that to our next generation of the workers, you know.
Okay. I think that's about it. And also, I'm just looking at the time. So what we
Yeah.
what we can do is I can share the email address with the audience, and then they can share some of the questions that I have and that they have, and then I will definitely get them to you. But just to finish it off again with a couple of slides. So just looking at some of the courses that we're offering here at EIT that are really related to today's topics. So we've got graduate certificate, Internet of Things, graduate diploma.
Sorry, Barry, to cut you off. Do you want to take control so you can move the slides?
It's all good. I'm able to move the slides. Is it
But we
moving on your?
can't, I can't see your slides moving.
You can just sync, I believe. Just try to sync.
If I stop sharing.
Oh yeah, you can stop sharing, and I'll take the control. Mm, What I'll do is just to see what is it um, Click, should be up now.
Yep.
I believe it's showing probably the slide, but I will. Yeah, are you able to see the screen now?
Yep.
Yeah. Okay. So some of the courses that are related to this topic today. So you'll see there we have a graduate diploma, a master's in industrial automation, and master's of electrical engineering. Upcoming courses, so you can always just go to our website and look at some of the courses that are coming that could be to also related to today's topic. So you can always go to eit.edu.au to read more on our programs and how to apply. And once again, we would like to invite you to our EIT Visual Open Day, which is happening on the 14th and to the 18th of October. So you can just go on the website to register if you want to know all things about our engineering programs, either to study online or to study on campus. So this is the time where we'll be discussing all EIT programs and just to get to know about what we do at EIT and some of the courses at EIT. Upcoming webinars, once again, you can just go to the website and go under events, ensure that you register so you don't miss out to this upcoming sessions. And yeah, so for those who have been asking in terms of the certificate of attendance, so you can just quickly scan the QR code here. I can also just share the link in the chat box. So if you can just go there and just ensure that you complete the form to get your certificate of attendance. I'll just put the link in the chat box now. Right, I just pasted the link in the chat box so you can just go and ensure that you complete or you get that done before the 7th of October. Unfortunately, after that, we cannot take any requests. So as soon as you can, just go and complete the form in order to request your certificate of attendance. I've also shared the link. If you can just go also, if you cannot be able to make use of the QR code and then just follow the link. Once again, we would love to hear your feedback, your comments, questions that you might have to our lecturer here. If you can just share with us at webinars@eit.edu.au, we will be sharing the questions with the lecturer, or otherwise share your feedback, share your comments, and thank you very much, everyone, for joining us. Dr. Imshes, thank you once again. Great presentation. And we're looking forward to see you soon on the line.
Thank you.
All right.
Thanks, everybody, for joining. Take care. Bye.
Thanks. Thanks, everyone. Cheers. Bye.